This is the video solution to a conservation of mechanical energy sample problem, or example problem. You were talking on the phone to your friend in the apartment below when you notice a ball traveling up past your window. You know that his window is 1.5 meters above the ground and yours is 4.5 meters up. The ball keeps passing your window when you take a video and use it to calculate the ball's velocity to be 4.5 meters per second. You say to him, "It must be traveling at 10 meters per second at your window." He says, "More like 6.5 meters per second. Who is correct? Good thing you're both nerdy and can settle this quickly using energy concepts. So here's the basic setup. I got the two windows, yours on top and then his on the bottom, and I want to figure out what the speed is on the bottom window. I need my two locations to compare. One is the question. The question talks about what's the speed at the bottom window, and I know the height there, so I can use that location. The other location is going to be the top window because I know the speed and the height at that location as well. To make my math a little bit easier, I'm going to make the lowest point equal to a height of 0. So if I call that 0, the upper point is going to be 4.5 minus 1.5, or 3 meters. Alright, so let's do the energy concepts. So this is conservation of energy, which means all the energy at his window, the sum of all the energies at his window, is equal to the sum of all the energies at the top window, or your window. So the kinetic plus potential energy due to gravity is equal to kinetic plus potential energy due to gravity at each location. So the KE and PE on the left is for his window, and the KE plus PE on the right is for your window. So now I've got to figure out when I have these values and when I don't have these values. So I'll go through and ask myself two simple questions. First, is it moving at this location? In other words, is the ball moving at his window? And it is, otherwise it wouldn't keep going up, so I'll keep that kinetic energy in my equation. Next question, at this spot, is it above the other location? In other words, at the lower window, his window, is it above the upper window? And it's definitely not. So that means there's not going to be any potential energy due to gravity at that location. Now on the other side, let's look at your window. At your window, you ask, is it moving at this location? And it is. In fact, you've measured it to be 4.5 meters per second. And then you ask, at this spot, is it above the other location? So it is above. It's the upper window. Your window is above his window, so it is above the other location. So you're going to keep that energy too. So that's how you create your equation. Now you put in the formulas for kinetic and potential energy. So it becomes 1/2 mv squared is equal to 1/2 mv squared plus mgh. It'd be very tempting to subtract out the 1/2 mv squared from each side, but you cannot do that because they're different velocities. One's for the velocity at his window, and one's the velocity at your window. But I can divide out the masses because there's a mass in every expression and it's the same ball in all instances. So they'll divide out. That leaves me with 1/2 v squared equals 1/2 v squared plus gh. Multiply both sides by 2, and I get v squared equals v squared plus 2gh. Again, tempting to subtract out those v squares, but you cannot because they're actually different values because they're at two different locations. So now let's isolate the velocity at his window, and that's v squared at your window plus 2gh. And if I put in the numbers in units, I get 8.89 meters per second for the velocity at his window. So as it turns out, neither one of us were correct.